Hey everyone, hey Kiev. So energized or tired? How do you feel today? So luckily, I'm gonna be the last on the architecture theme. So I'll try to make it as fun as I can, but let's see what I can do. So that's me. My name is Dmitro. I'm an engineering manager at Lyft. And this is what we're going to be talking about today. So first of all, I'm gonna explain to you all what's Lyft, why we're here, what we do here. Then I'm gonna briefly talk about my team, many teams that I have, and what these superb gentlemen and ladies are doing at Lyft. And then we will have an overview and slightly deeper dive into the pipeline that I would love to present to you today, which is called User Experience Inference Pipeline. And then it'll be a Q&A session. So let's start. So what is Lyft? So probably all of you know that Lyft is a rideshare company that mostly operates in USA and Canada, but recently that was a big news. We have purchased Freenow, and Freenow is a European brand, so we rapidly expand into Europe as well, and which is great. So we are serving and connecting people, founded in 2012. It's more like 13 years, and we have almost 25 million active riders. So we're big, we're growing strong, and let's talk about our purpose. So our purpose is to serve and connect. Rideshare is not just about calling a taxi. It's about the culture, it's about building the brand, it's about the values that we represent. So purpose is serve and connect, and let's briefly discuss about what is our values. So this is just one of the values that we embrace. There are four, at least four, but one of the ones I like is we all belong. So, which means that being a part of the culture where we celebrate our differences, it's not like in other areas and cultures and companies, we say like we provide equal opportunities. It's not that we just provide equal opportunities, but we're proud of that, and we celebrate the fact that we can give opportunities to multiple people from different genders, races, etc., in countries. That's why I'm here, Ukrainian, speaking in Ukraine about Lyft. So we also ensure that everyone has opportunity to succeed, and we try to build up for success anyone. We trust our leaders to make equitable decisions for all the team members, and we are supported in our work. So that's Lyft. Know us, maybe sooner we'll become better known in Ukraine. So the team, so the purpose of the team that I represent is we help other teams to make right decisions. The product that we provide is internal, it's totally for internal use, and basically it's data. We provide data for different use cases, and our users are something that we can call like a central market management. It's the place where we sit. So all the market management is around the data that we provide. Some examples could be there: driver, rider, finance, taxes, state of emergency, many other areas. Don't want to dig too deep into it. So the data sets and pipelines that our team owns, supports, and make shining as a diamond is financial pipelines, profits and losses, the gross bookings, net bookings, whatever, all of this is there on very granular level. So the user experience inference pipeline is the one that we're going to dive deep into. And centralized marketplace config and dashboards. This is just basically a place that glues together all the levers that I have presented here. Let's continue. And yeah, let's begin actually the pipeline architecture overview. But before we start, I need to explain to you all probably not many of you are of the rideshare experience, on the core event on which the pipeline is structured for. It's called a ride intent. So on the right, you see like an example of some probably old view of the Lyft mobile application. So what is a ride intent? A rider is me opening an application, and I just want to go from my home to my work, or like from the stadium to home, from after an event, after a match, or from here to home after everything is finished, because it's very hard to park here. So that's the right intent. So I input pickup, drop-off location, and then Lyft offers me some modes, options, coupons, anything could be there. So you can see it on your screen. So whenever I do this, it's called the ride intent. The difference between ride intent and ride is that ride is when I click, I pay, I get a driver match, I sit in the car and I go. If I just look here, I can close and go home. That's the ride intent. So what is our pipeline doing is it's like a huge control ecosystem. And I'll explain about what is a control ecosystem a little bit later. A couple of traits that it has is that it's always running. It has like a close to 100% SLA on the availability. Now it's taking a portion of the actual ride intents that we have seen on the previous picture. It talks, communicates to different prediction models and try to get metrics for some imaginal happenings of this ride intent. So in order to explain it to you a little bit in more details, let's say that we have only one production. We have only one production environment at which we define, configure how we operate. So whenever a user is doing a ride, there is only one way the user can see it. Of course, there could be A/B testing, many other things. But in general, it's just one. So the models can take the ride intent and put it into some world which has different rules. And in these rules, the ride could behave differently. The profit could be different. The time to wait the driver could be different. So this is why we're using these models. We don't own them. We just use them to see if we're making good decisions now or if we could make better decisions. So after that, we post-process the result, polish, which is called mixed adjustment that we're going to talk about later, and provide to the internal end users. This is a full pipeline. The architecture that it has, it's not something that you have never seen in your life. It's very simple but effective. And why it's interesting is the difference between classical application and the control system that I'm going to talk about now is that classic application is based on the user interacting with services, storing and retrieving the data. The requests have short life cycle, and the key challenge is the consistency of the state and the management of complex domains. So all the business logic, all the domains, references, relations, consistency, integrity, that's the classic application challenges. For the control system, we control the desired metrics via levers. So we tune them, and the metrics change. It's event-driven, so there is no interaction with the user. There is some predictability on how many of events there will be there, but it's not something that we can stop, put on hold, or somewhat throttle. It's multi-stage, and the full cycle of the request is taking a long time to be processed. It's a closed loop, so the results of the previous interaction might affect the new ones, the new coming. And the key challenge is achieving the desired state, removing all the noise, and actually use the set of actuators or levels in a way that we want the state to be. So let's have a look at the pipeline. And it consists of two different approaches for the architecture. In this pipeline, we see streaming and batch. So the streaming part starts with the write intent. So again, coming back, any user is looking at the write. We receive this intent, then we go to a service that is called a route sampler. One of the challenges of this intent is that there are a lot of duplicates. So many users in many areas could say, I want to go from this huge place into airport, for example. So I want to go from the center of New York to the airport. So this would generate so many write intents, and we don't need all of them. We just need like one of them. So we consider some write intents similar, and we try to dedupe them. So deduping is done as a first, just to make a clear write intent to look for. Then the filtered intents are arriving through a tool which is called route sampler. So route sampler identifies the specific write intents. Does it fall into which category, which is calling like the sampling grid? Like, is it a long or short distance ride? Is it, what ride mode is it? Is it like classic, normal, or is it, let's say, luxury? So there are many dimensions in identifying what type of a ride intent we see. And this sampling grid, for each category that we define for a ride, it clearly says what is the probability of this ride intent is sampled. What is sampling? Sampling is ride intent goes to prediction service, and it does the sampling, sending the event to models, and receiving back the results. So models for us are black boxes. And the results that models return are stored in a data set. So this whole part is a streaming pipeline. The other part is the batch pipeline, and there is one more thing on the batch pipeline that I'm going to say again. So the data that is stored, it needs to be compared apples to apples into the existing actual production data that is at Lyft. So we do query internal Lyft API on a prod, match with the results of the models, put into the data set, and have a very, very clean apples-to-apples comparison on what is it now and what it could be with the models that we used. After that, the data is mix adjusted. So mix adjustment is a process which is provided by data scientists that is taking all the raw data, removing everything that is not important, adding some weights into making what's important even more important. And then this data becomes the standard for all of our users. So let's first have a glance of the streaming part of the pipeline. So what do we want from it? So we want accurate prediction results, and we want them fast. What challenges we have? Models are external services that are out of our control. So we need a steady model that self-evolves, often contains duplicates, optimize the cost we want, and sometimes models return garbage. Threshold of a garbage is within a couple of %, and models should be rebalanced. So very simple flow of this streaming is very flat. We start with the event. Event is emitted, filtered, processed. For each event, a decision is made on whether to sample or no. Events are sampled through models, and data is stored. Very simple, linear pipeline, and some of the patterns, principles that we use when building or maintaining this pipeline, we're going to talk about now. So we use queues, distributed caches, without any examples of the specific technologies. Queues are used to ensure the steady throughput and delivery. Cache is used for example, quick lookup, as you know why caches are used. Deduping the event, for example, for a short period of time, as I previously said. So we use adapters. So each model basically is developed not by us. So we don't own models. Models are provided. So adapters basically adjust the interface of the model to our needs and unify it. So basically, it gives us a lot of extensibility. We use retries because models are not stable, and validation of the error to identify automatically if the model is actually living or is it not operating. So for guarantee of the quality and the SLAs, ensure the throughput, volume, accuracy of the data, and the availability of the service, we use DQ checks, monitoring, on-call practicing, probably you know that, I'm absolutely sure about that, rebalancing, and disaster recovery. That's the classical streaming pipeline. Now we go on to the batch part. So batch part consists of two absolutely independent, not live processes. One is called the robust sampler weights. Just to kindly remind you what's robust sampler is that we categorize the events, we put them in the buckets, and from each bucket, we want some portion of the events to be sampled. So the goal of this batch pipeline of the errors weights is we want as many samples as possible, right? The more data we have, the better it is for us. But models are expensive, and they have limits. So we need data as granular and as customizable as possible. Decisions that will be made are multidimensional, and some of the buckets are more important than the others. So buckets are not equal. Not like in our culture, where everything is equal, but buckets are not. So some of the use cases are also more important than the others. And we want sample distribution to actually align with the reality of the ride intents that happen at Lyft. So it has to be somewhat looking similar. And we also want at least minimum configured number of samples to be preserved per each bucket. So for this, we have this batch pipeline, which is called RS weights. So we take the short period of historical ride intent data from the left. We take the configuration of the DAG. DAG is some pipeline that is launched in the Airflow, let's call it this way. It's some data processing pipeline. So we take the configuration of it, we take the historical, glue together, do all the magic, recalculate, and we have configuration for all the buckets, where we define a probability for which the given ride within a given bucket will be sampled or no. So that's basically it. As I said, yeah, we apply configuration against the actual historical period of rides, preserve the distribution, preserve the actual maximum minimum values, and we get the data. So the next pipeline is a bit more sophisticated because we want stable metrics, but market is seasonal and market is unpredictable. We never know how many rides are we going to have today, how many rides are we going to have on the weekends, on some concert, in a place where there is like a football match. Anything can impact that. So there is a strict seasonality. So what's the mix adjustment doing is we filter out what's not important. We do reweights and rebalancing. Weights are taken into factor, for instance, time, distance, region of the ride intent. And weights are taken into account seasonality and anomalies. So, oops, wow, apologies. So yeah, let's have a look at the batch pipeline again. So stabilization effect of the mix adjustment is achieved by reweighting the collected metrics to the fixed baskets of goods, let's call it this way. So the factors that are implying the weights are distance buckets, time categories, sampling buckets, group weights, and they all are glued together, applied onto the data sets, and we have a very well-balanced data set as a result. So the benefit of this is, for example, if we have too much data somewhere, we just filter out what we don't want, what we just basically don't need. If we don't have enough of data, with this weighting mechanism, we can provide and add extra on top of what we have in the buckets where we need it, but we don't have enough. So this is mixed adjustment. As a result, we get our customers the perfect data that they need. A couple of words on general philosophy that we have. So the philosophy of this pipeline is, first of all, accuracy. So the data set has a 3-stage accuracy evaluation: real-time, automated DQ checks, and manual accuracy reviews. Timeliness. So we want data to be delivered as fast as possible. So the live data is delivered within minutes, and the aggregated data is delivered within T-1 SLA. This means that tomorrow you're going to get the data for today. So again, DQ checks. Stability is the cornerstone number 3. So the collected metrics are stabilized by a mix-adjusted post-processing pipeline, reweighted to a target use case. And the last one is explainability. So we want our users to understand how exactly the data was received, processed, and how can they use it. In order for our customers to get the clear understanding of that, we provide multiple dashboards, tools, and so they would be able to trace and point user-facing tables. So the 4 dashboards with 50+ charts are used to explain the metrics.